This is not a contact lens. It's a tiny hydrogel that could help restore vision for millions of people who suffer from a condition called keratoconus. It's a disease where the cornea, the clear front surface of the eye, gradually becomes thinner and weaker until it starts to bulge outward. As it changes shape, it can no longer properly focus light, leading to blurry vision or even vision loss. And here's the problem.
In the late stage of this disease, it requires donor tissues to be implanted, which are currently not available to over 98% of patients worldwide. My name is Shuo Li. I'm a material scientist at ETH Zurich. Currently, I'm a pioneer fellow where I lead the Augel project. At Augel, we're developing the next generation hydrogel-based corneal implant that's designed specifically to treat advanced keratoconus. I come from a family of ophthalmologists, so from a very young age, I was exposed to the profound impact of vision loss on people's life. The idea of Augel emerged specifically when I looked at the global transplant shortage. It was clear to me that we should not rely on human donors. We need an innovative material solution. The advantage of a synthetic material is that you can manufacture it in scale, and in this case, we also engineer it to mimic all the functional properties of human cornea, so that you can implant this material and it will function the same as a donor tissue, but at a better availability and much lower cost.
Successful animal trials have already shown that a common laser procedure can be used to insert the implant into the eye, and once inside, it can unfold and be positioned in place.
Our long-term vision is to move rapidly toward a pilot clinical study to establish safety and efficacy in human patients. This will be the most critical step to validate our goal as the donor-independent solution to restore vision for millions of keratoconus patients who are currently left untreated.